Welcome, this is a recorded session of the Post Quantum Cryptography Conference of the PKI Consortium. This conference would not have been possible without our sponsors, PQ Shield, SSL.com, Entrust, Keyfactor, HID Global, and the organizational support of the Post Quantum Cryptography Working Group of the PKI Consortium, and in particular, Entrust, Keyfactor, and Logius. Would you like to join the PKI Consortium? Go to pkic.org/join, or contact us if you would like to become a sponsor.
Corey Bonnell is our next speaker, technical strategist at DigiCert. He has over 15 years of engineering experience in several domains with a deep focus on public key infrastructure. And I will turn it over to him for the PQC Interoperability at the IETF.
Thanks. All right, good morning, everybody. Let's see if we can get this to work. All right, so I just want to start with the disclaimer, very similar to what Mike gave about participation in the IETF. I'm not here in any official capacity representing the IETF. I'm just participating there as an individual contributor. My experience with the IETF with this PQC hackathon is I've been involved with each one. So I have a bit of background, but this is not any official messaging or anything like that for the IETF. All right, that's me. I already got a great introduction. All right, so I thought I'd take a step back, starting here and giving a overall view of the hackathon process at the IETF and how that relates to the standardization process overall at the IETF, because I think that the hackathons provide very valuable input and insight into the standards development process. All right, so I'm going to start off with a quote from David Clark, internet pioneer, one of the very early legendary participants at the IETF. It says, "We reject kings, presidents, and voting. We believe in rough consensus and running code." This is basically a statement that the IETF wanted to be more practical application based as opposed to a design by committee approach taken by other standards bodies. And the hackathon is an embodiment of that philosophy. Clicked it once. Yeah. Any questions? All right. All right. All right. Okay. So yeah. So rough consensus and running code. I would say this is the two guiding principles of the IETF process. Rough consensus is, I would say, overall, but not necessarily unanimous agreement is sufficient to make decisions. I would say it's not perfectly numerically based. It's not a 80%. Say, if, for example, if some 80% of people agree to a specific thing, that might not be sufficient, actually, if the detractors actually have significant influence and insight. So it's really a judgment call made by the working group chairs on what is consensus. Another thing that hinges back on the philosophy on practical application is running code. And this is actual implementation of the specification trumps theoretical design. So if you have an example of someone drafting a specification that might not actually be implemented now, or there's no use case that's been readily identified for it, that work likely will not be adopted by a working group in IETF. So really, practical designs, concrete implementations are highly valued. All right. Yeah, so the IETF hackathons realize both of these principles. They produce concrete implementations of draft specifications. And also, I think, equally importantly, they identify problematic areas in drafts. So, if someone writes a draft implementation of a specification and they implement it incorrectly, they do interoperability testing with another hackathon participant. They interoperate correctly, but it turns out they both deviated from the specification. That means that probably the specification needs to be improved, and that certainly happened throughout the hackathons for PQC. Likewise, if there's areas where a person implements it one way, and then another person reads the text quite differently, but in a very reasonable manner, and they don't interoperate, that's also another indication that probably that specification needs to be improved. All right, so the hackathons, they're done with a hybrid model, so you don't necessarily have to participate in person. There's a tool called Gather, supported by the IETF. It's actually pretty slick. I have a little screenshot of it here. It's basically the virtual meeting space is organized with tables, and participants can gather around tables virtually, and then that automatically opens up the microphone and the video. So it's kind of and then you can also use the free tables to have impromptu breakout sessions. So it's really neat. It's far more seamless to use this than like trying to juggle different Zoom sessions or WebEx sessions or whatnot. The hackathons take place the weekend before the actual meetings for the IETF. It's actually kind of a little bit of a grueling schedule, even though it is pretty fun. It's 19 hours. You have 12 hours of a hackathon on local time Saturday, followed by 7 hours the next day. They give you 3 square meals, a lot of caffeine, and at the end of the day, they bring out the alcohol. So it's a good time. However, though, if you're participating remotely, you don't get any of that. You have to provide your own. So since I gave a general overview of the hackathon process at the IETF, I just kind of wanted to narrow it down now specifically to PQC. Mike went into great detail, excellent presentation on the details of the specific drafts. I don't want to go over that today because it'd just basically be a reiteration of what Mike said, plus, oh yeah, we implemented that. So I don't really want to talk about that. Did want to give an overview of the process for specific to PQC. Yeah, so I would say that the PQC hackathon at the IETF, I would consider it a proving ground for X509 interoperability. We focus, the majority of the focus right now for PQC at the IETF hackathons is the work being done in the LAMPS working group, which is, I would say, more or less specific to X509. You have certificates, CRLs, and then also some enrollment protocols. A couple folks are doing CMP, and then a couple folks are using applications as well, such as CMS. So we started back in November 2022 at the London Hackathon. We had a very small group. We were just a single table, maybe a half dozen folks, a couple more folks remotely. Since then, we had our most recent hackathon in Dublin at IETF 121 a couple months ago, and we had probably 25, 30 people participating both virtually and in person. So also too, when we first started out, it was mainly commercial providers, but now we have more participation from government agencies, open source projects, and as well as additional commercial providers. Kind of another thing too is when we first started out, libOQS was kind of the only open source library that provided the post quantum algorithms in an easy to use manner. So a lot of us were using those for the actual algorithm implementation, but since then, additional implementations have provided their own implementations of the algorithm. So we have much more diversity, so we're testing the actual algorithm implementations, in addition the actual format of the X509 certificates and CRLs. All right, so I have the main I guess staging point for collaboration for the hackathon project here. I have a QR code that jumps to the GitHub repository if you want to scan that. So one thing we have is an archive format for the artifacts that people generate. So say, for example, I have a library that generates X509 certificates or CRLs that use MLDSA. We have a specification in the repository that says, all right, well, put your trust anchor in this file, put your intermediate certificate in another file, and then that allows someone else to grab your files that you've uploaded, and then you can test to see whether or not you can verify those. So you can test for formatting errors or any problems in implementation. This thing's getting sensitive now. Okay. All right. Wow, it's fast now, too. All right. All right. Yeah, so one thing that was recently added, which is really neat, is before, a lot of the interoperability testing had to be done manually. Someone would have to go. I would grab somebody else's artifacts that they uploaded, download them, unpack them, run them through my testing suite. and then tell the results to that person manually. But what we have is additional tests that are run automatically, where we scan all the artifacts that people have uploaded and run automated tests against them using several open source libraries. Like, for example, we've integrated Bouncy Castle signature verification. We've implemented 7th Sense AI. They have a QuantCrypt open source implementation of these algorithms, and we use those in an automated fashion to provide more robust results. We take those results, and then we actually have on this repo some GitHub pages that display those in a nice tabular format. So instead of going and looking through all the result files, which are CSV files, manually, one by one, we gather all those up and then spit out some nice HTML files that have a nice comprehensive overview broken down by each algorithm. One thing that we had to do a couple years ago, especially before we had official OIDS from NIST, was the allocation of temporary OIDS. So one of the chief barriers to interoperability would be, how do you identify an LML-DSA public key inside a certificate? Well, the way how that's done is object identifiers. But absent a formal published specification with those identifiers, there'd be no way to interoperate. So we have on this page some have some temporary OIDS defined. We've since switched to the official NIST OIDS for the 3 FIPS algorithms, but there's still temporary OIDS for things such as composite signatures and chems. Another thing that we have, in addition to the work that we do at the on-site hackathon, is we have monthly catch-up meetings. This is a great collaboration point because we go, 4 months between the in-person meetings at IETF, but having these monthly meetings allows us to discuss things more quickly because, as Mike mentioned last presentation, these discussions are moving super fast. Like, you could just be a week removed from the discussion, you'd already be out of date. So the monthly meetings are very helpful in that regard. And here's an example of the test results, and I also have a QR code if you want to take a look at the GitHub page that we have. It has a breakdown of the interoperability testing results, broken down by provider, and also broken down by algorithm. So this table here, this algorithm submitted, is kind of like just a screenshot of the summary of each algorithm interoperability test. If you scroll down the page, it's broken down by algorithm with more detailed results. So it's a really nice way of seeing the overall state of things, because you can download the artifacts from the repo, examine them, and then take a look at this page to see how well those artifacts interoperate with implementations. All right, so I do want to cover that the standards that just a snippet of the standards that folks have implemented. Yeah, so we basically have the base certificate implementations for X509. People have done RSA Chem, for example, for CMS. There's work being done with CMP using post quantum algorithms. One thing is that when we first started back in November of 2022, we were really focused on dilithium, which is now MLDSA, and Sphinx Plus, which is now SLHDSA. And I think there's about a half dozen of us that did what we called generic composite at the time. The composite specs have then gone through several iterations, and they look vastly different than they did back then. But I think this work done at the hackathon actually helped to inform the approach that was taken in future versions of that draft. So also too, we noted some early on some interoperability problems. Like, for example, the dilithium certificates draft wasn't very clear on whether or not you embed the public key inside an octet string for the subject public key. So people were kind of back and forth on that one, and that kind of led us to the conclusion that, hey, this draft probably does need to be cleaned up a bit in terms of the language to make sure everyone can implement that cleanly. So that's another positive benefit. Another thing is that this implementing multiple algorithms at the same time that encompass multiple drafts allowed us to go and see a comparison for document reviews. You know, we made sure that, you know, for dilithium, for example, you wouldn't put your public key in an octet string. Likewise, for Sphinx Plus, you wouldn't put your public key in an octet string, because the drafts at that time were kind of inconsistent in that regard. So that was very helpful. Yeah, so I've given an overview of what we've done, and just wanted to provide some information on how to get involved. So I have a QR code here again that leads to the README file for the hackathon repo. It talks about the folder structure for the artifact archives to kind of give some insight on, you know, where the root keys, where the root certificates are, like or intermediate certificates are for testing. As I mentioned, we have monthly meetings, and if you want to get involved with those, you can contact our hackathon leader, John Gray. I'm sure he'll be happy to send you an invite. And also, if you attend in person at IETF, you know, we definitely welcome your participation. And then lastly, even if you don't want to be involved in submitting your own archives or things like that, you can still browse this repository, download the artifacts, and use those artifacts for your own internal interoperability testing. So in that regard, I think it's very valuable. All right, I think with that, I think that's it.
Do we have any questions from the local audience?
A quick question on during the hackathons or before the hackathons, how do you decide what to work on? Do you already come with a plan? When do you decide? And if you already decided what you're going to do during the next hackathon?
Yeah, I would say it really depends by hackathon or person by person. Sometimes you show up with no plan. You're just like, hey, I want to do something, and you kind of just get involved, help other people. I know, for example, someone showed up a couple hackathons ago. They weren't quite sure what they wanted to do before stepping foot in a room, but what they did was they took the NIST AVCP server that basically can be used for remote signing, and they wrapped that in order to generate and sign certificates. So that was just kind of like an idea that just popped in their head as they walked in the room. So it can be very spontaneous. Generally, at the monthly meetings, people share their plans for what they're doing at upcoming hackathons, so that provides some preparation for future collaboration too.
Okay, we do have a remote question now.
Okay.
Yeah, we got 2 remote questions. First of all, RFC 8784 outlines how to enhance the security of IKA version 2 by incorporating pre-shared keys mixing. However, as far as I know, there is no dedicated RFC specifically addressing its application with post quantum algorithms. Instead, there are RFCs on multiple key exchanges and multiple authentication methods. Will there be an RFC that serves as an asymmetric hybrid counterpart to RFC 8784? Thank you.
So I'm going to defer to Mike on that one. I'm not very familiar with IPsec. So.
I would defer to either Scott Fleur or Panos, but my understanding is there's a size problem, that you can't do a hybrid chem in IPsec in the same message because it overflows a hard-coded size limit, so they have to do nested essays. They have to first do EC and then later do ML chem because there's a hard size boundary problem. So I think there will never be a draft like that because it physically doesn't work within the predetermined buffer sizes.
Okay, I believe this is another question remote.
Yeah, from Matthew Olive, will DigiSearch start to embrace other than Thales HSMs in future deployments of your core services?
I'm going to plead the fifth on that one. I don't know if I can give future product plans here. So, yeah, I'd be happy to talk offline though, for sure.
Great.
Any other questions in the room?
First of all, thank you. I'm always very curious about how things evolve and how people get involved and what their drive is. And this sounds outer world for me. Why do you think that the number of attendees has evolved in such a short time? Why is it?
Yeah, so I mean, I think it's kind of in a similar vein how this conference has blown up over the past couple times. It's just, there's an increasing awareness of the quantum threat. We need a solution. We need migration plans, and people recognize that, and they want to get involved.
I'll throw you the curveball. What's the best war story that's come out of the hackathon?
Best war story.
Something that really should have worked and didn't, or something that everyone got wrong, or
Yeah, sure. All right. So a couple of us, I don't want to name specifications, but I don't know if I can do this without naming it. So a couple of us implemented Catalyst using the 2019 version of X509 that describes the way how you do signature calculation for these alternative public key certificates. And there was a passage in there that says when you calculate the to be signed, the signature for the to be signed message, you strip out the signature. And like we all read that and was like, well, obviously that makes sense. You didn't generate the signature yet, so you don't put the signature in. It turns out that in ASN1 for a certificate, signature is actually referring to the signature algorithm in the TBS structure. So we all were not calculating the TBS hash correctly because we were all including that signature algorithm as part of the TBS. I think there were 4 of us that did it all the same way. And, and someone later on piped up and were like, hey, I think we did this wrong. And yeah, sure enough, we did. So.
Any other questions in the room or remotely? Okay. Well, Corey, thank you very much.